All right, this is a multiple choice question. This is actually a fairly complex question. It says a tank contains 50 liters of oil at time t equals 4. So this is an important point that we're going to need. Oil is being pumped into the tank at a rate R of t. So R of t is a rate. It's measured in liters per hour and t is measured in hours. Selected values of R of t are given in the table above. Using a right-Riemann sum with 3 subintervals in data from the table, what is the approximation of the number of the liters of oil that are in the tank at time t equals 15? So we've got a lot of information here, but ultimately what this problem is about is that the integral of a rate gives us total change. We are given our rate function, so we're going to look for the integral of r of t. Now, this integral we can't figure out exactly because we're not given a function. So we're going to approximate this integral with a right-Riemann sum with 3 subintervals. So we're going to approximate the integral of r of t with r sub 3. We're also given these other 2 pieces of information, 50 liters of oil at t equals 4, and we're looking for the number of liters at t equals 15. So we've got to pull these into this integral. These get pulled into this integral by using the fundamental theorem of calculus. And when we do that, we're now going to do the integral of r of t from 4 to 15. This is going to give us the number of liters at 15 hours minus the number of liters at 4 hours. So we'll say n is equal to the number of liters. This we are going to approximate with r sub 3. The n sub 4, this is equal to 50. That was given to us. Between these 2 things, we will be able to solve for n sub 15. So let's do this right-Riemann sum. R sub 3 is going to be equal to the sum of the rectangles we get by looking at the right endpoint. So if I look at my first 2 points between 4 and 7, the width of that rectangle is 3, and I'm going to use the right point of 6.2. Then I go to my second point between 7, or my second interval between 7 and 12, that gives me a width of 5, and the right endpoint is 5.9. Similarly, I'm going to do the last interval, which is going to have a width of 3 and a height of 5.6. If we add all those values together, we get 64.9. 64.9 is an approximation of the integral from 4 to 15 of r of t. So 64.9 is going to go in to the equation above, and 64.9 is going to equal n of 15 minus 50. When we add 50, we get that n of 15 is equal to 114.9. So our correct solution is C.